What up, Algebra 2.1? This is Mr. Carlson, C-Squared Mathematics, and what we are going to be doing today is piecewise functions. If you have yet to watch the previous day's video over the intro of domain and range, the Desmos activity, then please go there and watch how I go through the Desmos activity, because I introduce to you what we call piecewise functions. So this lesson is actually going to be more in-depth, okay? We're going to go through some Bellwork preview or review. We already did the homework quiz, and then we're going to go through objective, central question, piecewise functions, and then closure. So this is the only question I have for you on the Bellwork. I'm going to go through it pretty quickly just because I want it to be review. I hope it's review. Average rate of change, it's probably the most important thing that we learned this week, to be honest, the average rate of change formula. And this formula is f of x sub 2 minus f of x sub 1 all over x sub 2 minus x sub 1. So this is my formula. Perfect. How do I solve this? Well, I have to look at this equation right here. So I put in brackets, I look at x sub 2 is 9, and I literally just substitute that in to my equation. So that means 9 squared and then plus, even the plus 3x, so plus, but not 3x, 3 times 9. That's my first part, the x sub 2 part. Minus, because it has built-in minus sign, built-in negative. And then f of x sub 1, I'm going to plug x sub 1 in here. So brackets, 1 squared plus 3 times 1. Brackets. I'm finding my outputs right here. And then, of course, following my formula, that's a 1, that's a 1, that's a 1. X sub 2 minus x sub 1, so this is 9, and then minus my x sub 1, which is 1. Okay, let's start solving this. 9 squared, keep the brackets here, is 81. And by the way, FYI, you can literally just plug this whole thing into Desmos, like exactly how you see it, without the brackets. Don't use the brackets. But if you use parentheses instead of brackets here, you can pretty much, I think you get the right answer, to be honest. So 81, and then I want to just solve it by hand just in case. 27, and then this is just 1, and this is plus 3. Of course, the bottom is 8. What does this equal? That's going to be 20, and then plus another 8. So 20 and plus another 8, so that's 109. And then minus 4, and then divided by 8. This is going to be 105, and then all over 8. Oops, sorry, I just noticed. Off my game. This right here actually equals 108, so I was just a little bit off. 108, so minus 4, that's just 104. And then if we take 104 divided by 8, 104 divided by 8. And we could do this on Desmos if we wanted or not, or we can just do a handheld calculator, but 104 divided by 8 is 13. Okay? Again, we can go to Desmos if we wanted and do 104 divided by 8 if we want. And we get 13. Either way, doesn't matter. We can do it. So I just wanted to review that real quick because honestly, it can get a little sticky, the math, especially with this new formula here, new slope formula. Okay, so I hope that makes sense. If you still need help with this, please come contact me. I hope you're not putting the graphing functions homework quiz too far behind. Okay, you need to be getting that done. So we're going to begin our Cornell notes actually with piecewise function. I really, really like this lesson. It's very entertaining, but it can get tricky. Okay, it can get tricky. So how can I write, graph, and evaluate piecewise functions? I'll show you how by interpreting domain, range, and function notation. And then how do I graph, write, and evaluate piecewise functions? So how? I pretty much just answered it for you by interpreting domain, range, and function notation, but I'm actually going to show you, demonstrate. So what is a piecewise function? Again, if you haven't watched the video for intro to domain and range Desmos activity, go to that because it's pretty phenomenal, okay? It actually teaches you about piecewise functions even there. So you're more prepared when you come here. Piecewise function is composed of two or more formulas or equations. Normally this would be very confusing, but each piece next to the formula is always with a domain interval. So then you take each piece and it actually makes a function. So it actually looks something like this. This is what the equation looks like. Now, if you were on the Desmos activity yesterday, you really just saw the graphs, what they look like. But we started graphing that, and it was nice. It was fine. We could find the domain and range. But here, now we're actually going to be taking an equation and putting all these equations together. But we're taking pieces of the equation. So what I usually like to do, guys, is I like to define piecewise functions as what I call the Frankenstein monster. You're really just piecing together different parts of other functions and then putting them together. I mean, and making into one big fat function, just like Frankenstein's monster. So the monster in Frankenstein was taken from dead body parts, tons of different dead body parts, put together, sewn together, and then like electrocuted. And then it was this awesome story. If you're not in Potter's Gothic lit, you should definitely be in it. But awesome story about how the monster is really not the monster at all. It's really Frankenstein, the Dr. Frankenstein, who is the true monster. Fantastic story. I mean, it won tons of awards. Read it. It's amazing. Gothic lit. So that's what we're doing here. We're going to take pieces of functions and putting them together. But before we get to that, let's take this one piecewise function, and what we're gonna do is evaluate it. What I mean by evaluating is finding the output. Okay. Now this is actually really simple. Okay. It's really what we're going to be doing is we're going to plug in something. Okay. Now what are these? Before I actually get to that, what are these little pieces? Okay, these are the functions. So I'm going to say these are what we call the actual functions. And then these right here, what is that? That is what we call the restrictions. Okay? Or more specifically, what we call the domain restrictions. So if Frankenstein's going to build a monster, right, he's going to take like this arm, but it cuts off right here, right? It cuts off right here, and then he attaches this whole arm onto someone else, right? And so what that piece is that he's attaching is the whole function. This whole arm would be the function. But what he's attaching to me right here is just that restriction. Like it stops right here to my hand. So right here to my hand to right here. That's the restriction. So you need both the restriction stopping right here and right here and the whole function itself in order to plug in to make me, okay? I hope that sort of makes sense. Whenever I explain that analogy, usually students try to get it. So let's erase this. Let's get actually into what it means to evaluate. Now, think about -3. What this is an x value. Okay, -3 is what we call the x value. Now, think about it. Am I going to plug this x value into a function in which it's greater than 1? Am I going to plug in -3 here, in other words? Well, we say if this is, x, is -3 greater than 1? Well, no. And if it's not, we're not going to plug it in there. Is it equal to 1? Is -3 equal to 1 right here? No. You see how these are kind of like conditions or restrictions here? So a condition, in other words, is what we call a restriction in mathematics. Okay. So now that I know it has to be there for this one, because -3 is less than 1, -3, the number, is less than 1, right? And since it follows and since it checks out that condition, I'm not going to be using this one. I'm not going to be using that one. I'm going to plug it in to that piece. So 2 times -3 minus 4, which is -6 minus 4, which of course is -10. What just happened here? We just have a point. What we found was -3, -10. That's what the point we found. So when we actually graph this beast, this piecewise function. What we're going to be seeing is this is a point on this piecewise function graph, -3, -10. That is an actual point here. Okay, so what I'm going to do is, now I'm going to erase all this. Now that I know it checks out, right? I'm going to go to the next one, and let's try to evaluate B. Think about it for a second as I'm kind of erasing. F of 4, what does F of 4 mean? F of 4, let's do purple, pinkish, whatever. F of 4, again, this is my x, right? Now 4, is it less than 1? No, it's not less than 1, so I can't use that one. Because 4 is not less than 1. Is it equal to 1? No. Is it greater than 1? Yeah, baby. Yes, it is, of course. Okay, so that means I'm going to plug it in here. So this is 4 squared minus 3. Okay, and so that will become 16 minus 3, which equals 13. So what is this point? This point right here is 4 comma 13. What did you plug in? 4. What did you get out? 13. Okay, now think about the other one. 1. There is one piece of this piecewise function that says x equals to 1. Remember, this is my x, so it has to be here. Now, you're saying, well, there's nothing to plug in. Okay, then it equals 8. That's it? That's really it? Yeah, guys, remember, what does f of x mean? F of x means y. What this is saying is it's saying y equals 2x minus 4 with some sort of piece. What it's also saying is y equals 8, where x equals 1. And then y equals x squared minus 3, where w, I don't even know why I was thinking that. Maybe I was kind of like twitched a little bit. Greater than 1. X is greater than 1. Now watch. This piece right here, that piece, look at it. Okay, f of x equals 8. Y equals 8. We know f of x is the same thing as y, correct? We know that's true. I've been saying that literally freaking all the time. Y equals f of x. F of x is big boy math. Y equals is algebra 1 puny math, okay? So this right here, f of x, is y. Now watch. Now when I go back and say, okay, well, y equals 8, where x equals 1. Look at that. Is that the same thing? Yes, because when I have y equals 8 and x equals 1, what I have is a point, okay? That's literally a point. When I say y equals this and x equals that, the two lines converge and they make a point, right? And so what this is saying is f of 1 equals 8 is the same thing as saying 1 comma 8 as an ordered pair, okay? I don't need something to plug in there, okay? It is that function already. I hope that makes sense. So let's go and continue on with evaluating here. Go ahead and try to pause the screen. Pause it. See if you can come up with the same answer. I'm going to work it out. I'm going to then briefly explain the evaluation process again and see if you can get the right answer. Okay, so these are the answers. I try to color code as much as possible for you. So green is going to be boxed or underlined in green. Red is going to be boxed or underlined red, and so forth. So the reason why I choose this green and this function is because 3 is greater than 0. Okay, so this is where x is greater than 0. And remember, 3 is an x. So I plug it in there. 15 plus 6 is 21. Here, -1, it is less than 0. It's a negative, so I have to plug it in the first one. -4 times -1 is 4. Minus 1 is, of course, 3. That is my point, -1, 3. And then I plug in 0. Now, I do it again for this function because it says greater than or equal to. So that means since it's equal to 0, I need to plug it in there. And so 5 times 0 is 0. And then plus 6 is, of course, plus 6. What's my point? 0, 6. So if you got these questions, that's awesome. That's amazing. Good job. Okay, good job. Let's move on, and you'll see something like this from Math Excel. This is an actual evaluation problem that will be on your homework quiz. By the way, it's on your homework quiz on Math Excel. Make sure you do it. It's very important. Okay. Now, Function p is defined as follows. Okay, there's a couple of different functions. You have this function, it's a little bit different. Now, what is the value of p of -1? Now, look at -1. Is it greater than or less than 0? Okay, it's less than. So, are you going to use this first one? No. Okay, so no, you're going to use this one. What is that going to look like? You're going to plug in p of -1, and this equals, so negative of a -1, negative of a -1 to the 5th power, plus -1 to the 4th power, plus 34 to the negative, or 34 times -1 minus 34. What does this equal? I'll give you a second to go ahead and calculate that on Desmos.com or your handy dandy calculator. So go ahead and do that for me, please. You should get -66. Okay? You should get -66. And that's great, that's fine. I don't care if it's a negative. That's what you're going to be putting in Math Excel, right? Awesome. Awesome, awesome. Now, we should know now how to evaluate piecewise functions. We just have to make sure we have the right piece. We have to look at the x value, and then we have to appropriately put that x value in the piece that the domain restriction is allowing it. Okay? Now, how do I graph? That's the big dog, okay? We're not going to go through a lot here. Probably just, I don't know, I may skip around. I probably won't go through all of them. I kind of just want to go through ones that you'll see on Math Excel. So that's probably about like 3. So I'll skip the ones that you more than likely won't see on Math Excel, the ones with the squares, just for the sake of time. You won't see anything like x squared or anything like that, but you will see like linear functions and stuff like that. So without further ado, let's get to it. First of all, you're going to look at the domain restrictions. That's the very, 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 very first step. You have to look at the domain restrictions, the x values for each piece. Okay, you're going to plot dots, okay, for less than or equal to, or greater than or equal to, or just plain equal to. And you're going to do open dots for less than or greater than. Now, some values may be repeated in one piece, and that's important. So, if that happens, x values will have 2 dots, one open or one closed, and that's fine. It just followed the pattern wherever it leads. Now, after dots are graphed, you're going to sketch each piece according to the domain value. And this is probably the hardest thing students have, this thing right here. Graph each piece that only covers its own domain x values. Pieces should not overlap. Okay? Otherwise, it would not be a function. Why? Because it wouldn't pass the vertical line test, right? Because then you would have functions on top of functions, and that does not pass the vertical line test. So they need to pass the vertical line test. I'm going to skip this one because it has a squared. So I'm going to go to this one because it's linear functions. And this is exactly what we need. Okay? So I think I have just 4 more examples left. I have 3 examples of this, and then we're going to get into how do I write a piecewise function, and then we're done, guys. So we're going to town on this. Let's continue going to town. First things first, my first step, I need to look at each piece, okay? So I'm going to look at this piece, and I'm actually going to take this, and I'm going to actually plug it in. Because I want to know where the ends of these pieces are. Okay, I'm going to plug it in. All right, so what I'm going to do is -4, and then times 0, and then -1. What does this equal? This equals -1. So what is my point? My point is 0, -1. Okay, that's the very first thing I want to do. So I'm going to do 0, -1 right here. Now watch, I'm not going to do a closed dot. I'm going to do an open dot. Why am I going to do open dot? Because it's less than. Okay, it's less than. Less than. Okay, now in red here, I'm going to plug 0 in here. So I'm going to do it off to this side, or actually I'm just going to do right underneath. So 5 times 0 and then plus 6 will just give me 6. That's great. But then I need a point. What is that? I plug 0 in and then I got 6 out. So this is 0 and then 6. And since it is equal to, watch my signs, it is equal to, I'm going to plug this point right here. Okay? Perfect. Now, Let's actually finish the red because we're on red right now. Think about it, guys. This is greater than or equal to 0. Greater than or equal to 0. I look at my x values right here. Which side does greater than go to? Is it over here? To the negative side? Is that greater than 0? No. Greater than 0 is over here. Which means when I graph this function, guys, when I graph this function, okay, for the second step, when I graph this function, I need to first, in red, I have a y equals 5x plus 6. My slope is 5 all over 1, and then my b value is 6, right? Which we already plotted. Now when I graph this function, I'm going to build it in a way that is greater than 0. So I'm not going to go this way. I'm going to go up 5, 1, 2, 3, 4, 5, over 1. And I'm going to do that. So it looks something, or it should look something like this, roughly. I mean, roughly. I mean, seriously, roughly. Okay. I'm not the perfect thing. I mean, yeah, it should look something like that. Okay. I should have started with the point. That's probably better. Now, when I look at my blue line, now why do I stop there? I'm going to show you. When I look at my blue line, what is my slope? My slope is -4. My b value is -1. Now this is less than 0. Now watch, guys. Why did I stop this red line here? Because this is at 0, and then if I extended it past, it would be not greater than 0. It would be less than 0. But the problem is the only piece that's less than 0 is this blue line. I'm trying to stress this because to me, students always get confused at this part. This is the domain restriction. If it's less than 0, I can only draw this line less than 0. I can't go above or greater than 0. So this is -4, 1, 2, 3, 4, and then all over 1 because this is all over 1, right? So all over 1. Now, normally I would do 1, 2, 3, 4 all over 1, and then I'll draw. But guess what? This is greater than 0. I cannot do this. I cannot do that, guys, because that's greater than 0. 0 is right here on the domain, right? And then it wouldn't be a function because it wouldn't pass the vertical line test. When I do the vertical line here, it hit here, continue down, it hit here. So what am I supposed to do? I'm supposed to build in the opposite direction. I'm supposed to build in the opposite direction. What does that mean? It means I go 1, 2, 3, 4 all over 1. 1, 2, 3, 4 all over 1. Okay? And then I'll try to make sure this is a little bit better for you. That's a little bit better. Kind of trail off the side there. Okay? But that's what it looked like, and that is what my function actually is. Okay? That is my end of my piecewise function. The reason why this is so difficult, guys, is because we need to pay attention to the restrictions. This says less than 0, which means the whole function is less than 0. If I were to continue it, sure, it would go like that, right? But I don't want to continue it because I cut that piece off, okay? I cut that piece off as per my restriction. So I'm going to take that piece off and not have it there. Okay? Not have it there. Sounds good? And then same thing for the red. The red, I want to cut that piece off. It would continue down right here, but because I want it greater than 0, and then it would pass, if I were to continue, it would pass right here into the negative range. I don't want that. So I need to make sure it stays here and above. Now, the cool part is this. I want to show you. Can Desmos actually graph this? Can I actually do this on Desmos? Yes. I will show you how. Now, watch this. I'm going to show you. I'm going to do y equals -4x minus 1. Now, this is what my actual point is. And I actually have it in blue, right? Yes? Watch. I'm going to use fancy braces and just do x is less than 0. What happened? What happened was I cut it off. Notice what I have here, and then notice what I have here. Okay, I'll even zoom in. Notice what I have here. Notice what I have here. Does it look similar? It does. Now watch this. When I continue, it is, 1. Okay, it is 1. But watch. Look what happens here. Oh man, right there. Boom. 0 undefined. Why is it undefined? Well, you see, kids, is that an equal to sign up there on the Desmos bar? No, it's not. It's not equal to, which means it's open, just like our graph. It's open. Okay? It's open. So if I go back, I trail all along, trace. I just trace it, go all the way to the end. Notice how it's open. Now, Desmos doesn't really show it that way, but it's open here. It is open. Okay? Let's graph the other graph. Let's make sure, let's do y equals 5x. Yep, 5x. And then plus 6. And then fancy braces. And then I'm going to do x is greater than or equal to 0. Now, of course, this is green. I don't want that. I can change it. So I can go to settings, change it into red, and I want red because that was my red color. Now, I trail along this line. Now notice it actually is a point. It's solid because it's equal to at that point, right? What does this mean? Watch. Do they look very similar? Yes, because they are, okay? They are the exact same thing. So can you use Desmos to actually just graph these? Sure, but the problem is you have to be careful because Desmos doesn't show you the open dots here, okay? They don't show you that. You need to trail along. Just grab it, trail along, and then see if it's actually closed or not. Same thing here. You need to trail along. See if it's actually closed, okay? Awesome. So I'm going to continue graphing it by hand, but every so now and then I will check it with Desmos. I'm not going to do this one because it's squared. So let's go on to this one. Graph the piecewise function and then determine the domain and range. So now, the last example, we didn't even determine the domain and range, right? We're going to determine the domain and range here. Let's graph this. Now these are a little bit tricky because they don't have any variables, right? They don't. But what is this really saying, guys? What this is saying is y equals -1 and y equals -6, where x is less than or equal to 0 and x is greater than or equal to 1. That's what it's saying. So I'm literally just going to take each piece, this one first. I'll do this one in red. I'll take this whole piece first and graph it in red. And then I'll take this whole next piece in blue, graph it in blue. Okay? So what does this look like? -1. Well, y equals -1. We already learned this, right? It crosses the y-axis. But watch what happens here. This is equal to, right? And this is saying it's going to be less than 0. So crosses at -1, the y-axis, but then it stops at 0. Stops at 0 here. Okay? The reason why it stops at 0 is the reason why it stops at x is less than 0 is because x is less than 0. Notice how it's pointing here. Okay? It's not going to continue. Could it continue on? Sure. But I'm cutting that piece off because that's not what my restriction says. Okay? Now let's do the blue. The blue, -6. Okay? Now it starts, let's move my face here. It starts at 1. Okay, so 1 right here. Okay, 1. And it's actually 1. Man. 1. Also equal to, but it's greater than. Okay, it's not less than 1, or not less than 0, it's greater than 0. It's definitely greater than 0, but it's greater than 1 specifically. Okay, I don't have this piece here, which brings me to my final point. This is what the correct graph looks like. Brings me to my final point in purple. There is a section in between here, right? That's not touching, correct? Yes or no? Yeah, there's a section in here that's not touching, which means when I go to do my domain is negative infinity to 0 brackets, but I have to jump from here to here, okay? Because that little gap in purple, there's a little gap there from 0 to 1. So I jump and then do 1 to positive infinity. That's what my domain will look like, okay? Now notice these 0 and 1s, they only correlate to the x's because they are x values. So that correlates to the x values because it's domain. Now watch this in green. Am I going to use these x values for range? No, I'm going to use this. But here's the problem. Does the graph exist at negative 10? No. Negative 8? No. Negative 7? No. Negative 6? Yeah. But negative 5? No. So it literally only exists at negative 6, but also it exists at negative 1. And this is a fancy case. So we're going to put fancy braces on it because the graph only exists at one solid line, like right here. It doesn't exist down here at all. It doesn't exist up here at all. It just exists at this line. That's it. Just at that line. So since it exists just at that line, you have this. And by the way, this is on your homework quiz. Okay, I'll tell you that right now. This question right here is on your homework quiz. Okay, so please make sure you understand. It's also on your homework. Okay, make sure you understand it, that there's a gap here. It's going to ask you for domain range. It's going to ask you for the proper graph. Can you plug this on Desmos? Sure, but is Desmos going to give you a domain and range? No, of course not. All right, and so you need to find the domain and range by yourself. Let's erase. Let's go through a couple more examples. I think this is the second to last example I have for you. So this one's a little bit more tricky, so let's do it. Now this right here, let's do first step right here. Let's plug negative 1 in. Okay, let's graph it. Plug negative 1 in. So this is 2, negative 1, and then minus 2. What does this equal? This equals negative 2 minus 2, which equals, I actually want to put equal to signs in here, which equals to 0, which is the same thing. Sorry, not 0. Oh, man. It's been a long day, I guess. Negative 4, which is the same thing as plugging negative 1, negative 4. So let's plot that point, negative 1, negative 4. So negative 1 right here, negative 4 all the way down here. Is it closed? Yes, because it's equal to. So I'm going to go ahead and plot that. Next thing I want to do is find my slope. So what's the slope of this? My slope is 2, where my b value is negative 2. Okay, now it's less than negative 1. So it's less than negative 1. So actually, think guys. My negative 2 is right here. That's my y-intercept. Can I, listen. Can I actually extend it right here and then continue down? The answer is a resounding no. Your b value does not help you here because your b value is past negative 1. Your b value negative 2 is 0, negative 2. Can I plug a point that's 0, negative 2 when this right here, it doesn't want you to go past this line. It doesn't want you to go past that line. You want to build like that. Okay? That's what you want to build. Why? Because it's less than negative 1. Okay? This is negative 1 right here. I need to go that way. That's less than negative 1. I need to build my function that way. I can't build right here. It may seem like I'm passionate about this, but I'm really not. What I'm passionate about is getting students the correct answer. And I see the same students over and over again, year after year after year, make the exact same mistakes. So I know what you guys are going to do. I'm no fool. You are going to want to extend that there. How do I know? Because A, I've been doing this for a while. And B, I was you. Okay, I wanted to do that as well. But you can't. You cannot do that. So what will this look like actually? Let's erase all this jazz. And let's go back. This point is negative 1, negative 4, negative 1, negative 4. And we set it as a closed dot because it's equal to right here. It's less than negative 1, so we're going to build down with my slope. I don't care about my b value. With my slope. Boom, boom, all over. Boom, boom, all over. Boom, boom, all over right here. What does this look like? It looks like this. That's what my piece looks like. In blue, what will it look like for this piece? Let's plug negative 1 in right here. So negative times negative 1 plus 1 equals 1 plus 1 equals 2. Fantastic. So I plugged in a negative 1, but I got 2 out. So I'm going to plug in negative 1, but I got 2. Now that's an open. It's not equal to, so it's open. So I'm going to do that. Now this is also greater than negative 1. So what's my slope here? My slope is negative 1. What's my b value? My b value is 1. Okay? My b value is 1. So I'm going to go down because that's my slope. So down 1 over 1. Now notice how this piece does include your b value. Because it is greater, your b value is greater than, following my restriction, greater than 1. And then I can just continue with my slope, my little points here. Get some more, just so I can get a nice little straight line here. And then I screwed it up. But this is what it looks like. Can we graph this on Desmos? Absolutely. Am I going to? No. I'm going to go straight to domain. What's my domain? Where the graph exists, my friends. Where does the graph exist? Well, if this goes down all the way over here, will exist all the way down to negative infinity? Yes, it will, because it has an arrow. It will continue down forever, and it will eventually hit every single x value. So negative infinity. Okay, read math left to right, and then I stop right here. But wait, do I really stop? Think about it. Do I really stop? Now, I stop right here, and of course, I can align myself with this point, right? This doesn't give me a point, but I can align myself with that point. Now, if I continue, will it actually continue down all the way over here? Yes. To where? Well, if that continued down to negative infinity, this continues down to positive infinity as the arrow goes forever and ever and ever and ever down that way. So this domain is actually negative infinity to positive infinity. Now notice I read it left to right. Notice how I did my negatives first. And notice how this little jump here is not really a jump because you still cross all my x values even though that there's a little gap. It's actually not a really gap. It's not truly a gap. It's not a hole is what we would say. Okay? Let's go to my range. Bottoms up, range. So clearly graphs exist down here, right? And they go on forever down there, right? So that means I'm going to continue to say negative 50. Now watch. When I'm continuing up my graph, up my graph, up my graph, there may be a break here in this graph, but is there a break here in this graph? No. So I can still continue because there's no break here. Now, where do I get a break in this graph where it stops existing? Where does it stop existing? Right here. What is that value? What's that y value? I'm looking at y values here. Bottoms up, y values, not x values, not inputs. I'm looking at outputs. What value is that on my y-axis? 2. Is that closed or open? It is definitely open. This is my range. Sweet. Okay, so that is also going to be on your homework quiz. I'm so happy it's giving you just homework quiz questions all over, you know? Let's erase this, and then let's finally get to what we call writing. Writing piecewise functions. Okay, writing piecewise functions. So if you have yet to get this, pause it, get it down, so we can go to writing. What is writing piecewise functions? You have 3 pieces. Okay, 1. You have 2. And then you have 3. And what is this going to look like? The first step that I'm going to do, I'm going to label the steps. First of all, the first thing you need to do is find your functions. If you're given a problem like this, you're going to find functions. Okay? Second step you're going to do is you're going to find domain intervals. Okay? That's your restrictions. Third step you're going to do is you're going to build your actual piecewise. Okay? So let's keep those in mind. Let's build our actual piecewise. Ready? So first things first, what's my first function? My first function, actually, let's go here. What's my first step? My first step is to find my functions. Okay? So my first step is to find my functions. What's my blue function? Well, let's start with y equals. Now look. Okay? Look. So it's basically a horizontal line. Now if we continued this line, where would it hit? This would hit at 2, right? Okay? And it would continue on forever, correct? So it's a horizontal line, hits the y-axis, and it continues at 2. So that means that this is a really rather easy. There's no slope. It's y equals 2. That's my line. Okay? And you're like, what? What? That's literally the definition of a line. If I continued all the way through, where does it hit? 2. So this is y equals 2. Now, we'll get to the restrictions later. I just want to know the function. Okay? I just want to know the function. That's the easiest part. Second part, second piece. What's this function? Well, it is a line, so I need to find my y values. I need to find my my slope, right? I need to find the slope, and I need to find the y-intercept. So what's my slope? Well, first off, I look at this point, and I can go up 1 and then over 2. Okay, that's another point. Up 1 and then over 2. All right, and up 1 over 2. All right. So that means rise 1 over 2, 2. Okay, so that means 1 all over 2x. Why am I including x? mx plus b, baby. mx plus b. Okay, so that's why. It's a line. I need to include mx plus b. Now, if you're saying the first one didn't include x, it was a line because it crossed the only the y-axis. Is it crossing the x-axis at all? No. So why are you going to include an x if it doesn't cross the x-axis? Okay, it only includes the y, so you're only going to it only cuts through the y-axis, so you're only going to have the y. That's why. Get it? Puns. Boom. What's my b? Well, it crosses the y-axis right here, and that is 2. So that means plus 2. Awesome. We're going to town on this. We'll get to the restrictions later. Okay. 3. What's my third? All right. Now let's try to continue. First of all, I need to find my slope. So let's just pick an arbitrary point right here and then go up. So 1 and then over 1. Well, that's easy. 1 all over 1. That's easy. Wow. Okay. So that means my y-intercept is right here. My slope is just 1, so I'm just going to put an x because that's what it is. Okay, my slope is 1, but then my y-intercept is here. Okay, and I'm going to have to count 1, 2, 3, 4, 5, 6, 7, 8. So 8. So plus 8. Now, before we move on, notice this line. The other one was a positive slope. This line, though, is it a positive slope? We learned just a couple of days ago that if it looks like this and it falls, that means it's a negative slope. Okay? I went up over to the left 1. I went up over to the left 1. So it's not a positive 1 slope. This is a negative 1 slope. Okay? So awesome. We got our 3 functions. Okay? I'm going to erase all this. And now what we're going to be doing is finding, as per my steps here, we're going to be finding, second thing, we're going to be finding my intervals. Okay? So what is my interval for my first function? Okay? All right. Well, it seems like it goes on all the way over here, right? But then stops right here at this value. What's that value? So 1, 2, 3, 4. So this is negative 4. Stops at negative 4. What's that inequality? the inequality is x is less than negative 4. So there's solutions x that are less than negative 4, but it has to point that way. Think of it like a number line. That's what we did, right? If you had a number line right here, right, and you squiggled it, just like Algebra 1, you would have that, right? So that's very simple. We should think about our Algebra 1 skills in that, where we had an open dot because it's not equal to, and less than means pointing that way. I hope you're making that connection. Please, please, please make that connection. Awesome. So that is my first restriction. My second restriction. Okay, this one is still maybe a little bit tricky, but it's still good. Now think about it. Just like your Algebra 1 days, it's included here, negative 4, so that's easy, so negative 4. But your value, your function, is in between negative 4 and 2, and that's open. So that means your x is in between negative 4 and 2. Now 2 is open. Is negative 4 open? No, it's not. It's not. Okay? If we wanted to put this in domain interval notation, it would be negative 4, comma 2. And then also, just for kicks and giggles, if we wanted to put this in interval notation, this would be negative infinity to negative 4. But really, piecewise functions just include the inequality. The inequality here. They only include the inequality. Finally, let's go to 3. Okay, now where does it start? 2, and it's a closed dot, so that means x, and then it goes all the way over here, so it has to be greater than this 2. So that means greater than 2. Perfect. We have everything. You know what that means? We can build it. So my function, f of x, is this. F of x equals, fancy braces, okay? Starting right here, 2, where x is less than negative 4. This one is 1/2 x plus 2, where negative 4 is greater than or equal to x, but at the same time less than 2. Okay? And this one is going to be negative x plus 8. And then, of course, x is greater than 2. This is my final answer. Sweet. Okay, sweet. So that, my friends, is piecewise functions. Okay? You're not going to see this writing piecewise functions on any quiz or test, by the way. It's just something that's fun. Okay? Fun for you to do. All right. Now, what did we learn? We learned 3 things. We learned how to evaluate algebraically. We learned how to graph piecewise functions graphically. And then we learned how to write piecewise functions as well. Okay? So make sure you do your homework. Please, please, please do your homework. We do have a homework quiz tomorrow along with our Desmos activity. Remember, retakes for the retakes are available this week. Actually, no, they're not, because we didn't even have a quiz. We didn't have a quiz at all, so no, not available this week. So retakes are not available this week. They're not due Friday, so don't worry about that. But we do have a homework quiz tomorrow, so make sure you do the homework. If you have any other questions or concerns, please, please, please let me know. This is C-Squared Mathematics. I'm Mr. Carlson. Be sure to like and subscribe. Peace out.